Hi, Olivier here. I've got bad news for you. Despite all you might hear around, embedded development is not easy. And it's not bound to become any easier. Yes, there are technologies that make it more approachable, especially to non embedded developers. Think about Arduino or Wilderness Labs Meadow. Tooling is becoming richer and richer, and device management solutions exist that simplify IoT builders and operators' life. But at the end of the day, software at the edge, I mean at the very tiny end of the edge on the embedded devices, has become way more complex than 10 years ago. I had the chance to visit my friend Samir Bounab, CEO at Wilderness, to discuss exactly that. Samir and his teams, they have a deep understanding and expertise in building and deploying custom embedded devices at scale, and the topic has become personal for Samir. If you're interested, watch this new episode of the IoT Show. Hey everyone, this is the IoT Show. I'm Olivier, and we are hosted at Wilderness today. And I'm with Samir. Samir, how are you doing?
Hello, I'm good. I'm good.
Well,
Thanks a lot for.
Thanks for having me here. That's the first IoT show that we're doing outdoors, or at least not, remotely from home. So thank you for that. So before we get into the topic of today, which is discussing embedded development, how hard it is, and Wilderness and how Wilderness can help OEMs and other types of customers, I want you to make a short introduction about yourself. Not Wilderness yet, just yourself. Who's Samir?
Yeah, okay, thanks. No, and thanks a lot for hosting that here. So I'm Samir Bounab. I'm the CEO of Wilderness, a design house that is specialized in embedded software. And about me, to answer your question, I started IoT somehow before embedded.
Okay.
Because I was in the telco industry when I started. So I was working with those big telco guys a few years back. So it was already about connected stuff, but it was more servers and mobile things. So I had the chance of doing that in Europe, in South America as well, and a bit in North America as well. So that was probably 15 years ago. And then I went to non-technological field for a few years. Created a venture studio with a few partners, and we were working in industry, fooding, a lot of different things. It was really fascinating, though I was missing a bit the high tech.
Yeah.
So I came back to my first love, and this is how I joined Wilderness to develop the brand further. It was called differently at that time. It was Arduino Embedded, and then we moved to a different brand and positioning. And so I could kind of combine my former background of that IoT and telco thing with more of the electronic and software world we are in today. And as of now, I'm based here in Seattle, as you can see, even though Wilderness headquarters is in Lyon, but we have offices everywhere in the Western world. And so here we are.
Yeah. So down there in the offices, it's pretty much speaking French. Lots of French people over here, right?
Especially today, it's Thanksgiving week.
And this is water. All good there. So you've been navigating from tech. You learned tech at school, then you went into more of a business, but also kind of in areas where you were learning a lot about the customers themselves and their needs and so on. And that's interesting because even though you've not spent all your career in tech, you've spent it at understanding people's problem, and that's actually relevant for our conversation, because embedded, as we'll see, is very often something that is about a custom piece of hardware, custom piece of software that is meant to serve a specific purpose, which is like the customer's purpose, what they need, right? And my understanding, I know for a fact, you spend a lot of time understanding the customer's need. And that's also based on the fact you've been on their side, or you've been beyond the tech business, and you have this touch, I would say. So before we get into the conversation, we were chatting about technology and so on. And in our domain, there's a term that is being used a lot that makes you like that, which is edge, the edge. It's been used for everything, and we're not talking about the web browser. We're talking about technology, right? Not the web browser, but the edge. What is your definition? Let's define the edge, right? Let's, as starting point, what is the edge from your perspective?
Yeah, no, that's a really good question, and you're right. I'm a bit passionate about the topic because I think we are all losing a lot of time using wrong words somehow. And I have a lot of discussion with partners where somehow it can be even pointless because we're not discussing about the same topic. So I really appreciate the question, and that allows to frame the discussion. And I'm not saying my definition is right. I'm just saying
a definition.
It's a definition.
Yeah.
When we refer and we take you as edge devices, those are the devices that are at the edge or at the end of the network. So we for us, it's end devices, such as a coffee machine, a crane, a medical device, a handheld device. All those things are for us edge devices. And indeed, I see a lot of technology vendors that are using different wordings. Sometimes edge is a server, sometimes edge is a gateway. And that leads to a lot of misunderstanding of what are the good framework for edge. Well, if you're talking about the server, it's absolutely not the same discussion as for an end device. In terms of light edge, sometimes you hear things light edge, heavy edge, and heavy edge people will refer as routers and big servers. Light edge, small gateways. Again, that's not what I'm talking about when we speak about edge, and everything we'll talk about today hopefully will be about end devices.
End devices
that are built by OEMs that wants to innovate on their end devices.
Okay. So tinier device, tiny edge.
Well, if a crane is tiny, then why not?
let's be old fashioned and call that embedded.
Yeah.
Right? I think that makes sense. I think it's important that you remind people that this word edge is used by many people in different ways. So here we're talking about the embedded part of that story.
That's true.
So what is the state of the art? Where are we at? Or state of the union, I would say, right? The technologies that have evolved, hardware, software ones. What are the main trends? What are the big things that you think have been the fundamental changes in the last decade or so?
Well, there is one thing which definitely has moved the market is the predominance of MPU in many scenarios for different reasons. Definitely let's divide the world into two things, MPU and MCU. I know there are different other things like FPGA, etc. But let's make it simple, MCU versus MPU. Definitely the cost of MPU right now is way lower than before. The market expectation from the end user are higher as well in terms of user interface, in terms of smartness of devices.
Yeah.
And all that has led a lot of OEMs and end devices to have new screens, a bigger screen, connectivity, security, etc. And therefore, as the MPU were getting cheaper as well, we clearly see a big trend toward MPU on the markets. And devices that will have, I don't know, a coffee machine 10 years ago would have stupid 8 buttons and an MCU to control it. Now has a big screen with many features. Yeah. Well, you need an MPU for that. So that's a big thing we have seen. And that comes with a lot of software challenges, obviously, which are interesting for us, but challenging for customers. Yeah. So that's definitely one thing is, that's that predominance of MPU in many scenarios that were not imaginable 10 years ago, to be honest.
Yeah, because of cost.
Absolutely.
Okay. So you would imagine that bringing technology from the world of servers and PCs, because MPUs, are coming from that, or maybe are closer to that world than the microcontrollers themselves. So that means you can start using bigger operating systems, Windows, Linux, this kind of things. So that means you can use software technology that are coming from a well-known world, right? So you would think that things are becoming simpler, easier on the world of embedded. Is that really the case?
I would say yes and no. At least this is what most people can think out of the embedded market. And we've seen a lot of players that were trying to tackle that wave and kind of, they saw the opportunity for the Wild West to be a bit more structured. Okay. Because definitely the edge or the embedded side of things has always been I call that a Wild West, a lot of protocols, a lot of different technologies, a lot of different form factor, because it's kind of, it's a given based on the physical constraints of what we work on. A laptop is a laptop, mobile phone is a mobile phone, the form factor is somehow the same, and the condition in which you use a laptop are mostly the same. Yeah. well, in between a handheld device, an industrial crane, a medical device, a satellite or exoskeleton, there is a ton of different things between the temperature, the battery or not battery, the form factor, the price point as well. Not every embedded devices can be $1,000 like this one.
Yeah.
$2,000, sorry. Yeah, you're right. Inflation hits.
Look, that one can do that, right?
Whoa, nice.
Anyways.
So indeed, we have that physical constraint that drives a lot of complexity in the embedded world, which a lot of people overlook, and think that you can come with your IT frameworks and standards and apply that to millions of devices. Well, no, it's not the case. And in OEM, an OEM will have maybe 5,000 devices per year, 10,000 devices per year, 50,000, 100,000 for the most.
Yeah.
And that drives as well design choices that will be different from a laptop where you have millions of devices, or even a car where you have a different scalability. So I would say yes and no, because obviously there are some standards, and we see that, for instance, Yocto in the Linux field is gaining traction and has a standard in the embedded parts. Android has some good shares. So there are some more standards than 10 years ago, but you have always new things popping up. A new radio standard, a new OS, a new security layer, a new framework here and there. So it's always moving. And there is always a part of customization, even though you can still do some standardization. And so on your question about the big trends, that first thing about MCU versus MPU. And then in the MPU itself, we've seen some interesting things that I can elaborate on about the move to modules on the markets. That's fairly new, and we've seen a switch in the last 10 years.
For those who are not familiar, the notion here is that we are getting to a point where I wouldn't say the hardware is becoming standardized, but it's no longer about buying a chip or a microprocessor and putting that on a PCB and then routing everything, right? So now you're in a place where you can get SoCs, or now SOMs, right? SOMs, that basically aggregate a certain number of functionality with components, and you just buy these off the shelf, right? This is the trend in the hardware.
Absolutely. Because the level of complexity hardware-wise has increased as well with the MPU, because those chip vendor makes a good job of making a better MPU. But then you have a lot more complexity to build an electronic board. And so if you look at our customer base in the last 5 years, it has switched from people doing what we call chip down design. So I select a chip from whoever vendor, and I will build my board around that, exactly custom to my need, and then I'll build the motherboard and the casing, etc. Now a lot of OEMs are being what you said, modules. So it's a pre-existing board with a set of features which is exactly adapted to the chip, and then they will build their motherboard around it. Motherboard having just the peripherals or specific things.
Got it.
And all the point there is to save time and complexity. You will save 6, 9, 12 months in a design. You don't have certification to go through, like the radio certification you need to go through. We all know that in hardware you can have all kind of issues on your runs, and that can take time for something which is not so differentiating for your device. If you have a module that works, maybe you'll pay a bit more, but you save a lot of time, and time to market is key. So we clearly see that many customers, except the ones that have huge volume, where they prefer to have custom for price reason, will go to a module strategy, and there are plenty of module vendors such as Advantech, AD-Link, Catec, Contron, Avnet Embedded, etc. All those brands that provide those modules, and that market is really mature now. The second step we've seen there is from those proprietary module to standards, which is a good sign, because when in a market you have standards, back to your point, it allows faster innovation and less pain for end customers. So definitely I would say that 80% of the new design we see now are based on modules one way or another in the MPU world.
So it begs the question, right, which is, you would assume, lots of assumption today, but you would assume that if you have a somewhat standardized hardware, that the software that is developed for adapting an OS or applications to the hardware, and we call that a board support package, drivers and so on, you would assume that this is available and given, right? So something that final customers can integrate their board with a module pretty easily, right? Is that really the case?
I need to be really careful on what I say here.
It's just the two of us. It's like it's a reality. We're doing a reality check, right? You're exposed to what the customers come to you because it doesn't work.
Yeah.
So why is that? What's going on here?
So I think there are different reasons. Indeed, I tend to agree with you. I think the module value proposition is a bit incomplete as of now, because we tell the customer, Mr. Customer, come, you have a board which is ready, you save 9 or 12 months.
Yeah.
Oh, but by the way, you'll have headache on software for another 12 months. So I think it's a shame. And even though I love to support this customer on professional services, I think it's a problem in our markets because it reduces the speed of innovation, and even it makes some product to just fail and not see the light at all, because the more you wait, the more you are with a moving target. And a great product innovation now, maybe in 2 years, and we know that our world is changing fast, it's not a good, it's no longer a good idea. So indeed, as of now, it can happen where you have a nice module and then you have issue with software for different reasons. One is a module maker will build a BSP or software enablement, let's say, which is built for a whole product line and to make sure that the customer can start with something. It doesn't mean that it guarantees you that it's production ready. And a lot of people, it is, but in most of the cases, it's not, for different reasons. Because there are too many things in that software, because it's for different products, and you want just what you need in embedded, especially in embedded. You want to make sure that you use your software wisely. Two, probably the software culture is a bit new to those players for the majority. And as for software guys, they tend to overlook hardware problems. I think hardware guys tend to overlook a bit the software problems. So CI/CD, how to build a software factory, how do you build a really security from low level to the cloud. OTA looks easy, but it's not. So there is a lot of factors like that makes that the end customer who can spend seriously 12 months to have something that works. And again, we all know that in between something that works and something which is industrial,
it takes some more time.
It takes some more time. It can be double the time or triple the time. So definitely there is that missing part of enablement. For sure, there are professional services houses like Witekio that will help and bridge the gap. Some modules makers have professional services to try to help as well. Some customers that have steady enough product development cycles have a team to do that because they launch new product here and there. So people figure out that's a given because we see new products on the market. But the time is far from being efficient, that's for sure.
What about tooling? So we're at a stage where software is coming big time on the hardware more than ever. So software developers like the tools, right? The tools to build your special OS, minimize eventually the amount of software that is useless. So you guys have been putting together something that we wanted to talk a little bit about today. Just as an introduction, we'll do a deep dive later. But tell me a bit about the tooling that you guys are offering.
Maybe I'll step back just a bit on that in terms of OSs that people can use right now on an MPU. Because let's say I'm an OEM, and I think it's important for the audience to understand what's the design journey there. I'm an OEM, I want to have a nice product with a nice UI and connectivity and big screen and different things for my new coffee machine or my dehumidifier or my ventilator or my fridge or my crane. I'll go for an MPU ARM-based because there is a really good cost versus performance equation. And then I want an OS to run on it because I want to put my application on it. So, and in here I have multiple choices. As of now, and I'm not influencing anyone, just as a fact, 70% of people go to Linux. Because on ARM, there is a different distribution, including Yocto, which is a Linux base. Some will go to Android. And what we see, a minority might go to Windows if they have Windows application to port from a past device to a new one. in the good old time when you had like Windows Embedded or Microsoft, you would have an editor that would maintain that and that you can. Sorry for the term, but that you can slap if it doesn't work.
Yeah.
they guarantee you it should work. Yes, you have updates. You can call someone.
Yeah.
And it's not the same for Linux and Android, and especially Linux. When you go Yocto, or it's good because it's really modular.
Yeah.
It's open source, so it's free. It's free like a Puppet is free.
Yeah.
So and then you enter a new world, and OEMs are not completely comfortable with that because they go to Linux because it's free. They start their developments, and then they realize that okay, you do one-shot design. Then you need to have maintenance. You have cybersecurity vulnerabilities to monitor. You have updates to do on your device. You have new things to do. It's a living thing, the Linux, and there is no editor behind except some specific pro-market players. So on top of having those challenging during the design, they will have those challenging during the lifetime management. So our approach was, we are a professional services house. So we've seen probably 2,000 projects in the last 20 years, which makes a bunch.
Yeah.
And we continue to, our mission is to enable our customer to not need us.
Okay.
They work with us, they do the design. Hopefully we have some ongoing business with them for the long run, but the IP is for them in everything we do. So we wanted to do something that could combine best of both worlds, which is we want to accelerate them in their developments, so give them some tooling and IP, but we don't want to lock them like some other people or providers that will offer SaaS solution or proprietary solution. So our approach is to take open source solution and build up IP on top. And then when we deliver that to the customer, when we sell that to the customer, he will pay one time and he has the source code. So there is absolutely no lock-in, which is to me really important in the product innovation field. It's not like IT where it's a cost center and it's infrastructure or operation of the company. It cannot be considered as core business for a company to have servers, IP, software. Product innovation, it's your product. It's what you sell to your customer. So I consider that it's normal that OEM want to control what's in it.
Fair.
If the core of their business is dependent of another vendor, I think it's a strategical mistake. So I get why they want that. And this is our approach. And so we've been developing a new spin-off of Witekio, because Witekio does professional services. So we wanted to have a different spin-off that does product and IP. And those IP include Yocto meta layer, so something on top of Linux that will save you a few months to get the CI/CD, software factory, the security, the over-the-air updates, everything you need to get started and to build your application on top right away. And that will be from day one compatible with the hardware you have.
And done right.
And done right.
And that's important because we're talking about the complexity of using the existing bits today, right? So someone can, as an OEM, can go and buy a SOM and then get the BSP and then try on their own to make it work, right? Getting rid of what is not needed and so on. But it's hard. And at the end of the day, the OEM, they are experts in building a special device for a special market. They're not expert in the embedded software or the IoT technologies themselves. And so they need someone that gives them the ability for them to do it right from the get-go, right?
No, you're right. And its idea is to remove friction. It needs to go fast. It needs to be right, because then you will, if you don't do it, you will pay the bill at some point. And it's the whole idea to remove friction to allow faster innovation.
So I'm not sure you named it. So a set of meta bricks for Yocto. What's the name of that product?
So the name is the Embedded Kit.
The Embedded Kit. Easy to remember.
The Embedded Kit, as we speak a lot about kits in our industry. And it has a Yocto meta layer. It has a testing suite called Pluma to do all the Linux test suites, all the CV monitoring to monitor your vulnerabilities. That will be mandatory in US and in Europe soon, in any case, for most of OEMs.
By the way.
And a connectivity tooling as well to connect you easily to Azure or to your on-premise cloud without spending months of redeveloping your own IoT platform somehow.
That sounds like a dream for an OEM, right?
Yeah, so best of both worlds.
Why would they not go there? It's like everything, right? You have to think about the initial investment that will make your development sustainable, right, longer term, and then you'll make money faster and sooner as well. Awesome. Well, Samir, that was great. So if you're interested in this conversation, want to learn more, we'll put some info and contact info for Witekio, for Samir as well. Well, I hope that we'll see more of the embedded kit soon on the IoT show as well, because we'll double click on Pluma and so on, because these are very interesting tools that we've not seen in a long time. We're talking about, I remembered, feel old, like power platform builder and, this kind of tools. So I really look forward to do that deep dive. Samir, thanks a lot for having me here.
Thanks, Olivier.
Okay.
See you soon.
Thanks everyone for tuning in.
Bye.
Bye.